This is Vishwas. Today, three important topics. That is, first one is separating funnel, right? So let's start with our first topic, that is separating funnel, two immiscible liquids. So liquids means, let's take an example of oil. We will perform an activity regarding oil and water. So let us try to separate kerosene oil with water using separating funnel. Pour the mixture of kerosene oil and water in a separating and let it stand undisturbed for some time so that separate layers of oil and water are formed. Let's see. This is basically what we call a separating funnel, right? This is a funnel, and here the tap has been fitted over here. So liquid with high density is at the bottom, and liquid with low density is at. Open the tap, what will happen? The water will pour into the tap and will get separated in another beaker, and we are going to collect it in another. But the upper layer which is left in the separating funnel, that is of kerosene oil. So सारा का सारा लिक्विड जो आप येलो कलर से देख रहे हैं हाई आएगा टैप ओपन करते हुए, तो ये रहेगा सारा का सारा लो डेंसिटी लिक्विड दैट इज केरोसिन ऑयल। तो ऐसे हम दोनों लिक्विड्स को सेपरेट कर सकते हैं, राइट? ओके, नेक्स्ट इज applications. To separate mixture of kerosene oil and water, extraction of iron from its ore. Lightly slag is removed from the top by this method to leave the molten iron at the bottom. So जो impurities होती हैं वो ऊपर आ जाती हैं, उसको remove कर दिया जाता है, and the iron which molten iron which is left at the bottom is separated. So the principle is that to miscible separate liquid density. So we can separate the two liquids depending upon their density. Third is sublimation. That's again an important one. To separate a sublimable component from a non-sublimable component, like ammonium chloride changes directly into solid state on heating. To separate such mixtures that contain a sublimable volatile content with non-sublimable impurity. This we have already covered in our previous video also. So what happens in this case is we are taking a china dish. On that china dish, we are keeping some ammonium chloride salt over it, right? And we are providing heat Bunsen burner. So what will happen? The ammonium chloride will absorb the heat and get vaporized. And after vaporization, we are not letting that ammonium chloride gas to move out of the container. We can do it by plugging a cotton plug at the end, and with the help of cotton plug we are not letting the gap to escape. So what will happen after a few time when the gas gets evaporated and the mixture gets cooled down a little bit, you can able to see solidified ammonium chloride at these corners of the funnel, right? So in this way we can separate out two immiscible liquids by just heating. So this is ammonium chloride, and naphthalene ball or salt we can do for all these. Next one is chromatography. To separate solutes that can dissolve in the same solvent. So chromatography is a process to separate the solutes that can dissolve in the same solvent, जो एक ही same solvent के अंदर dissolve हो. So is this is the dye in blue black ink with a single color activity? Let's see the activity. Take a thin strip of filter paper. हमने filter paper लिया or draw a line on it using a pencil approximately 3 centimeter above the lower edge. Lower edge से 3 centimeter above filter हमने एक line बना दी. Put a drop of ink, uh, water soluble. The water soluble ink should be there, or you can take the fountain pens or ink pens at the center of the line and let it dry. और वो जो लाइन आपने बनाई उसके ऊपर आप इंक की ड्रॉप गिरेंगे, उसे ड्राई होने देंगे. लोअर द फिल्टर पेपर इनटू अ जार, glass beaker, test tube containing water so that the drop of ink on the paper is just above the water level. See this? Something like this. This is the line and you have put some drop of ink over here, right? So what will happen? Lower the filter paper into Ganda to Bodia containing water so that the drop of the ink is just above the water level. अब ये जो drops हैं ink की आप देख रहे हैं water level के just ऊपर है, and left it undisturbed. What will happen? Watch carefully as the water level rises up on the filter paper. Record your observation. धीरे filter paper क्या करता है? पानी को absorb कर लेता है. It will absorb water from the container. So what will happen? What do you observe on the filter paper as the water rises on it? So what you have observed? Let's see. And do you obtain different colors on the paper strip? And what according to you can be the reason? So the ink that we use has water on the as the solvent and the dye as is soluble in it. So water इसमें solvent था और dye इसमें soluble थी, solute थी basically. As the water rises on the filter paper, it takes along with it dye particles. So वो dye particles को अपने साथ साथ लेकर जा रहा था. Usually a dye is a mixture of two or more colors. So the color component that is more soluble in water rises faster. जो कंपोनेंट जो कलर वाटर के अंदर ज्यादा सॉल्युबल होता है वो जल्दी ऊपर राइज करता है, और जो कम सॉल्युबल होता है वो धीरे धीरे राइज करता है. मतलब आपको डिफरेंट डिफरेंट कलर्स उसमें देखने को मिल सकते हैं. यू कैन एबल टू सी डिफरेंट कलर्स इन दैट. So the process of separation of components of a mixture is called chromatography. So in this way ink. So this basically is known as chromatography, where chroma means color in Greek language, and this technique was used by the separation of color. So this name was known as chromatography. So this is the definition of chromatography. Chromatography is the technique used for separation of those solutes that dissolve in the same solvent. तो बेसिकली क्या है, दो सोल्यूट दो डिफरेंट डिफरेंट कलर्स हैं जो वाटर सॉल्वेंट की तरह एक्ट कर रहे हैं, उसके अंदर डिजॉल्व हैं और एक इंक बना रहे हैं, राइट. सो न्यू टेक्निक्स ऑफ chromatography has been developed. You will study about chromatography in higher classes, but I will make you study in this class only by showing you a video after completing this distillation topic. So, to separate miscible liquids, the boiling points of liquids must be sufficiently different. So, distillation is a process you have already done in previous classes might be. So, distillation में हम boiling points के ऊपर काम करते हैं, right? So, if there will be a difference between the boiling points of two substances, we can able to process the distillation process. There should be a major difference. But if there is not a major difference, then we have to opt for the fractional distillation. So, see the activity. Let us try to separate acetone and water. So now in this activity we are going to take a mixture of acetone and water. So what you have to do is these are the steps. Basically you have to take a thermometer and put it in a put the mixture in a distillation flask and fit the thermometer on it. And I will make you see the apparatus how you have to fit it right now. See this, right? So what happens in this case is this is a Bunsen burner, right? Okay. So what is going on? Water vapor is there. So how come there is a mixture of salt and water in this case? This is basically fractional distillation. Okay. So there is a little bit difference between distillation and fractional distillation, right? So I will tell you by showing a video. So let's understand what's the process in taking out in both the cases. So मिक्सर हमने लिया है, इसके अंदर नीचे से बंसन बर्नर से हमने हीट प्रोवाइड किया. जिसका बॉइलिंग पॉइंट कम होगा वो जल्दी वेपराइज होगा. बॉइलिंग पॉइंट वेपराइज होने की वजह से जो वेपर होगा मटेरियल जिसका बॉइलिंग पॉइंट कम था वो कहाँ जाएगा, इस ट्यूब के अंदर. दिस इज नोन एज बेसिकली कंडेंसर. सो इसके अंदर जाएगा तो यहाँ पे हम क्या पढ़ा होता है, कूलिंग, कूल्ड वाटर. तो वेपर आ रहा है वो एक एनर्जी उसने एब्जॉर्ब किया हुआ है तो गर्म होगा, राइट. इट्स इन द फॉर्म ऑफ अ स्टीम. तो उसे कूल डाउन करने के लिए हमने यहाँ पे कंडेंसर लगाया. अब ये जो कोल्ड वाटर है इससे वो जो स्टीम से वो हीट एब्जॉर्ब करेगा कोल्ड वाटर, हॉट होके बाहर हो जाएगा, राइट। तो अंदर जो वेपर्स थे अब वो किसमें कन्वर्ट हो गए, लिक्विड फॉर्म में, एंड देन वी आर गोइंग टू कलेक्ट इट इन this beaker, right? So this is the basic process behind the distillation and fractional distillation. The basic difference between both of them is this is fractional distillation. Why? Because we are having a fractionating column over here, right? If we are not having this, the simple thing is water will vaporize and the mixture will left behind. Or if we were taking alcohol and water, so what will happen? Alcohol has a little bit lesser boiling point than water, so alcohol will evaporate and water will be left behind. So that's distillation. But if there are two things which are not having any much difference between their boiling points, we have to use a fractional distillation process. Now I will make you see a animated video. With the help of that, you can able to visualize the thing, how this method is going to work. In that video, I am going to explain you first of all the concepts that we have done, that is distillation, fractional distillation, separating funnel, and chromatography, right? So ready to watch that video? Just let's start.
Separating funnels are used for liquid-liquid extraction, also known as solvent extraction. They come in different shapes and volumes, but always ensure that you do not fill the separating funnel more than 2/3 full. Also make sure to clamp around the ground glass joint at the top of the separating funnel. Before transferring any liquids into the funnel, always ensure the stop clock is closed. When the tap is vertical, the stop clock is open, and when the tap is horizontal, the stop clock is closed. When pouring liquids, you may wish to use a measuring cylinder or long-stemmed funnel to prevent spillages. When both the solution and the extraction solvent have been added, layers will begin to form. One layer is the aqueous phase and the other layer is the organic phase. Here we added colour to the aqueous and organic layers to show the separation more clearly, but it is more common for both layers to be colourless. The key to the separation of layers in a separating funnel is density. The bottom layer is the more dense solution, but this is not always the aqueous phase. For example, the separating funnel on the right has the orange aqueous phase on the bottom and the yellow organic phase on the top, because here ethyl has been added to our aqueous solution of water. The density of water is 1 gram per centimetre cubed, but ethyl our organic phase, has a smaller density of 0.9 grams per centimetre cubed, and hence the organic phase forms the top layer. But on the left-hand separating funnel, the orange aqueous phase forms the top layer and the bottom layer is the yellow organic phase. This is because an organic solvent called dichloromethane, DCM, was added to water, and DCM has a density of 1.3 grams per centimetre cubed. Hence DCM is more dense than water, so the bottom layer on the left-hand separating funnel is the organic phase. In order to carry out an efficient extraction, we must ensure that the organic and aqueous layers are thoroughly mixed. We do this by inverting the funnel. To begin with, you should remove the funnel from the clamp or ring, holding it securely with both hands, and then turn the funnel upside down. When upside down, open the tap to release the pressure that may have built up during the mixing. Then using both hands, invert the funnel 2 to 3 times before opening the tap to release the pressure again. To ensure maximum mixing and maximum separation, you should repeat the process of 2 to 3 inversions followed by the opening of the tap another 5 to 10 times. Then securely attach the separating funnel back in the clamp or ring and watch the layers begin to separate. This separation shows that the dye that we added has gone into the organic phase, which is why the bottom aqueous phase has lost its colour. Now it is time to extract the layers. Always start by removing the stopper from the top of the funnel. Open the tap and drain the first layer into a clean conical flask. Make sure you start to close the tap as the bottom layer drains out to slow the rate of flow and to help you correctly close the tap when you can no longer see the separation between the two layers. Put this conical flask to one side and collect the remaining layer into a new clean conical flask. To obtain the most accurate results, it is best to repeat the whole process twice more, by pouring back in the layer you wish to extract more from. In this case, we want to extract the organic orange layer, but this is not always the case. You add new extraction solvent from a measuring cylinder, not from the layer you have just extracted into a conical flask. And it is better to collect the layer that you want, in this case the organic layer, into a new clean conical flask after each separation. By repeating the extraction process, it ensures maximum separation and therefore helps to maximise the yield of your final product. You then are left with a conical flask of a purified solution that contains your final product. However, you often need to still remove some more impurities, so it is common for this to be followed by distillation or recrystallization.
This video shows an example of a chromatography experiment. The goal of the experiment is to separate the different pigments of ink which are present in a wet erase marker, which we'll see right here. So a vis-a-vis marker is wet erase, which means that the pigments are water soluble. We'll start our experiment by drawing a line with the marker on the chromatography paper. Then what we want to do is insert that chromatography paper into a beaker with a small volume of water in it. We can see that the water will start to rise up the chromatography paper because of capillary action. You'll note this is happening very quickly because this is 16 times speed playback. We can see that the ink, which originally looked black, is starting to separate into different colors. This is because the different pigments have different properties. Some of them are heavier, some are lighter, some are more soluble in water, some are less. Because of these differing properties, all of the different colors are going to travel at different speeds. And by the completion of our experiment, we should see some very nice separation of the different pigment colors. Now, to do analysis of our results, what we're going to want to do is to measure the distance traveled by each pigment. Let's pause here for a moment. So I want to measure the maximum distance traveled by the water and then by each different pigment starting at the line drawn on the paper. To be fair, we should be comparing the distance traveled by the water starting from the same point where the pigment started traveling. So we'll measure all of our distances starting at this point. Looks like the maximum distance traveled by the water reaches about to here, and then we can measure the maximum distance traveled by each of the different pigments. Let's continue our playback. The final part of our analysis will be to calculate an RF value. This is going to be a different calculated number for each different color pigment. For a pigment which travels exactly the same distance traveled by water, which is the solvent or the mobile phase in this experiment, the RF value would calculate to be 1. That's because the distance traveled by the pigment would be the same as the distance traveled by the water. If we had a pigment color which travels half the distance of the water, the RF value for that pigment would be 0.5.
Our topic for today is simple distillation.
I need to remove this nail polish. nail polish can be removed by acetone. Acetone can be obtained by simple distillation.
The process of heating a liquid mixture to form vapor and then cooling that vapor to get a liquid is called simple distillation. Distillation is used to purify a liquid by separating the components of a liquid mixture. Let us perform an activity to understand simple distillation. Take a mixture of acetone and water in a distillation flask. Put a thermometer in it. Connect the flask to a water condenser. The condenser has cold water running through its jacket to keep the temperature cool. Keep a beaker at the outlet of the condenser. Heat the mixture, keeping an eye on the thermometer. When the temperature hits 56 degrees Celsius, acetone starts to vaporize. These vapors condense in the water condenser. The condensed acetone gets collected in the beaker. When all the acetone vaporizes, water is left in the flask. Acetone is collected in the beaker. In this way, acetone and water get separated by simple distillation. Boiling point of water is 100 degrees Celsius. Boiling point of acetone is 56 degrees Celsius. As there is sufficient difference between their boiling points, these components can be separated by simple distillation. Simple distillation does not work properly when difference between two boiling points is less than 25 degrees Celsius. This is because the components do not get separated and purified completely. If we repeat this process multiple times, we will be able to separate these two components. However, as this is very time-consuming, a special type of distillation called fractional distillation is used.